Going on to topic 2 of module 2, the exercise set. We're looking for concept reinforcement. Classify each of the following statements as either true or false. And I'm adding why. So what I would like you to do somewhere in your lecture booklets, the one that you're assigned, write down true or false and why. So we'll give you a moment to look at them if you don't have your textbook with you, and we'll pause the tape. Okay, we'll check to see how you did. I have in red the false statements and in blue the true statements. And let's just get over or go over what you have said as to the why. Well, the coefficient of this term is actually 3. The 5 is an exponent. Now the product of two monomials is a monomial. We see here. This is a monomial, a monomial. When we multiply it, we get a monomial. The product of a monomial and a binomial is found using the distributive law, which we see illustrated here in number 15. We would just distribute that using the distributive law. To simplify the product of two binomials, we often need to combine like terms. Now in the FOIL, where our outers and inners are multiplied, here we get a negative 2a from multiplying our outers, and our inners give us a positive 12a. So these are like terms, so we have to combine them. Now there are cases when this doesn't occur, but in this case and in most cases, when we're multiplying binomials, that is why this is true. We often, it's not always, but often. Now in FOIL, we only use the FOIL when we're doing a binomial times a binomial. Therefore, this is false. The square of a binomial is the difference of two squares. Well, this is the square of a binomial, and you get this. If you multiply these, you get the difference of perfect squares. So squaring a binomial does not give you this. And we might mention, I guess in our next topic, the product of the sum and difference of the same two terms is a binomial. So the sum and difference of the same two terms gives you a binomial. Because when you FOIL this, the middle terms that would have occurred like here would cancel out through subtraction, and you end up with a binomial. This is called the difference of perfect squares. Now this is a name, I don't know if we mentioned it, it's called a perfect square trinomial that comes from multiplying a binomial squared. Now these have a special name too. These are called conjugates. And when you multiply conjugates, you get the difference of perfect squares, as a rule. Okay, and then our last one, in general. This is sort of like the distributive principle here, that you would get f of a. This part is correct, but you would also get f of 5 here, which is not what they're showing. So, since they've put the sign here, does not equal, That's why this statement is true. Okay, a little short review again, and hopefully useful.